Hey guys, welcome back to another episode of Home Supply How-Tos. Today we're going to be changing this contactor, and we're going to go over a couple of things that you may notice on the contactor that's probably causing the issue. First thing you want to do before you start servicing the system is you want to pull the disconnect out, set it on top. That way it's nice and safe to work on. Alright guys, so here's some common reasons on why you should change your contactor. On here you got your low voltage on each side, and what you sometimes may find is even though you have power going to it, that switch isn't closing. And the reason for that is you may have a bad coil on here and you want to read anywhere between 12 to 16 ohms across it. The other thing you may find is maybe some bugs. I've seen a lot of ants go in that contactor and they prevent the contactor from actually closing and allowing power to go through. The other thing you may find is maybe the contactor is actually stuck and the unit isn't stopping from running, and that could cause the system to freeze up. And so changing this contactor will prevent those things from happening, and it'll kick your unit on. So we confirmed on this system that the indoor is calling for cooling, the fan has kicked on, and now we've already tested this capacitor and we've confirmed that this is good. And so the contactor is the next thing we're going to look at to make sure that this is working properly. So some of the things you may be testing on this contactor to ensure that it's this component is we've already checked our capacitor and we've confirmed that that is new and good and it's in range. But when we test here on this contactor, we have 120 volts here going to ground. We have 120 volts going here to ground. We have 120 at the top, but we are missing voltage on this left side. And that means there's something inside preventing this contactor from closing and allowing the proper voltage to go through on this leg. And so in this case, we would replace that contactor to make sure we got power going through both legs of the system. So we're going to go ahead and get started. We've already removed the panel for you. The power has already been disconnected. And so here's our main line voltage that's going to go into this contactor. And what we're going to do is we're going to identify where these wires go. Usually they're all color coded and labeled, but what you want to do is just match one for one of where these wires are going. In this case, we've got these two yellow wires are going to go on one side of your contactor here. The other set of wires are black and they're going to go on the left side of the contactor here. These two wires here on the side are your low voltage, and then everything that's here with the screws on the top and the bottom is for high voltage. And so down here we have another wire that's yellow, and we have nothing on this side other than this black wire here. So we got white, yellow, two yellows here, two blacks, and then our low voltage wiring here. So we're going to remove these two low voltage wires. And we're going to undo our wiring here. Take your needle nose. And then for these two here, there are no screws on the top, or actually there's one screw right here on the side. It's holding everything down. 1/4" screw. And we have two more wires here. And there you go. Here's your old contactor. So we've removed the contactor off of the panel here, and some of the things that you want to look at is the condition of it. So sometimes with it closing so many times, you'll get debris inside of it. Maybe you'll find an insect or some ants. I've seen that happen before where it's preventing the contactor from closing. The other thing you want to check is the ohm resistance across it, and you can do that with your multimeter. And you want to be anywhere between 12 to 16 ohms. If you're anything above or below that, usually it indicates that your coil is shorted on this contactor. And then with that short, it may also tie into having a bad fuse up at your circuit board, and that's what's causing your system to lose power. So we're checking here, our ohms is 14 ohms, so that's well within range. So in this case, this one is good. The other things that you want to check is if your system is running non-stop. Sometimes when the contactor closes, it welds itself together, and in that case you want to replace it as well. So if it's not stopping, even though the unit or the thermostat says it's satisfied, you have to kill power here to shut the unit off. Check your contactor here and make sure that it's not welded together. In that case, it will require you to replace it as well. All right. So we've confirmed that the contactor is good. It's closing properly, and your readings are on here, so you want to make sure you get a match on the readings. This is a 24-volt contactor, and so you're supposed to have 120 volts on the top side. One lead is 120 and one lead is 120. That'll give you 240, and that's what this system requires. So we're going to put this back on. Our wiring should be the exact same. We're going to mount that screw back on. We had our black wires on the left side. Our yellow wires are on the right. There's one black wire. Yellow wire. And all these pins are connected to the same side. So for the black, you got 4 pins. For the yellow, you got 4 pins, and you can match them to any of those on the same side. Got our high voltage here. Got our low voltage on one side, and you'll hear it click if everything is good. There it goes. And now we'll confirm, make sure everything kicks on. I got my high voltage back on, my yellow wires on my yellow side, black wires on the black side. Contactor's pulled in, and now we'll check power. We can test amps. 0.5 on our fan. 6.8 on our compressor. We can also check our voltage. 244 on the bottom. 244 on the top, and that's what you want. Thanks for watching. Like and subscribe.